Bismillahirrahmanirrahim. Assalamu alaikum, students. Today I am before you with another lecture. We will discuss the idea of a wave. Now, what is a wave? Wave is fundamentally a disturbance. Now, this disturbance can occur in various situations, in various physical quantities. For example, if this is the surface of some water body, if you throw a pebble at this point, what happens? Ripples are created, and those ripples move radially outward from this point of disturbance. So you can see the energy goes radially away along the surface of water from the point of disturbance. Wherever that energy reaches, what happens, I should say, wave reaches, the molecules of water are disturbed with respect to their undisturbed position. So here the displacement of the molecules of the water surface are changing. Displacement is changing. I should say displacement is wavy because that displacement changes with time, just like sine function. If we plot sine theta versus theta, we get this shape. Now, when some quantity changes this way, the way sine theta changes, the sine function changes, or the cos function changes, we call those changes as sinusoidal. Sino, sinusoidal is sinusoidal, right? Now, waves, this is not only one wave. I'm talking right now. Now, my energy is the sound which I produce goes through air in my room in the form of a longitudinal wave, which is called sound wave. You can have a sound wave. Now, when sound wave goes through air, for example, what happens? The pressure in the air molecules changes sinusoidally with time and with position. So we that time call it, if we express the sound wave as a change in pressure, we call it pressure wave. Now when sound wave goes through the medium, you can also express it as a displacement wave because the medium particles also oscillate at their respective positions. Now, when you express the sound wave in terms of the displacement of the particles at that time, we call it displacement wave. So, in general, wave is a disturbance. Now, this disturbance can occur in different physical quantities. In case of water wave, the disturbance is taking place in the displacement of the molecules of the water. In sound wave, the disturbance is in pressure, disturbance is in displacement of the medium particles. Now, whenever some quantity changes this way, sinusoidally, we call it a sinusoidal wave. Wave can be non-sinusoidal, but in general, we can express any complex wave which is periodic in nature as a combination of sine waves. So sine wave is an important wave. There is another kind of wave which is called electromagnetic wave. What is electromagnetic wave? Light is an electromagnetic. Now, electromagnetic wave it doesn't require any medium to propagate from one point to another point. This is important. Sound wave needs medium to move from one point to another point. For example, if you are talking with your friend in some room, if there is no air present in the room, you cannot talk, sound cannot propagate through air, propagate through vacuum. It needs a medium. Similarly, if there is no water, for example, between this point P and point Q, there is no water in between. Now, the wave starting from P cannot reach Q because it needs a medium to propagate. Now, such waves which require material medium to propagate from one point to another point, they are called mechanical waves. They are called mechanical waves. So, sound is a mechanical wave. The wave produced in the surface of water is a mechanical wave. If I produce a wave in some string, for example, I take a string and wiggle it in this direction, then the wave will propagate through it. Now, if someone cuts the string, then the wave cannot move forward the other portion of the string on the other side of the cut because it is a mechanical wave. So, wave produced in the string, sound wave, all such waves which require medium to go through or mechanical waves. But electromagnetic waves, now you know electromagnetic waves are many. One is our light. Our light, by that I mean visible light. You know, visible light is a collection of electromagnetic waves which have wavelength in the range 400 nanometer to 700 nanometer. Remember, 1 nanometer is 10 raised power minus 9 meter, right? 10 raised power minus 9 meter. So, this visible light is a collection of electromagnetic waves which can produce sensation even in our eye. So, light is an electromagnetic wave. There are other kinds of electromagnetic waves ultraviolet, gamma rays, radio waves, microwaves, X rays. They all move through the space, you know, at a speed of c equal 3 into 10 raised power 8 meter per second. Right? Now, these electromagnetic waves, whether it is visible light or microwaves, radio waves, infrared, ultraviolet, X rays, or gamma rays, they do not require any medium to propagate. Remember, we receive light from sun. This is sun, and this is earth. This is you know the distance between the center of sun and center of earth r is 150 billion meters. 150 billion meters is a large distance. So when light leaves sun, it reaches us on the earth. Even most of the space between sun and earth is empty. The atmosphere of earth is only up to certain kilometers. That means this light can travel without the assistance of any material medium. So, you know, in electromagnetic wave, we have an electric field which is sinusoidally changing with time. We have a magnetic field which is sinusoidally changing with time. And changing electric field produces changing magnetic field. Changing magnetic field in turn produces changing electric field. Both are sinusoidally changing with time, and both are perpendicular to each other and perpendicular to the direction of the propagation of wave. Since the electric field and magnetic field variations feed each other, it doesn't require any medium to move from one point to another point. So we can have wave of different kinds. We classify these waves into two kinds on the basis whether they require material medium to move or not. We can have mechanical or electromagnetic waves. Then we classify waves on the basis of other criterion. For example, if I have a slinky like this, and you give a jerk in this direction, let this be x direction. You can see the wave through this slinky will go along x direction with certain speed, and you if chuck any element of this slinky, it is oscillating in the same direction this way. So in this particular wave, the vibration of the medium particles is in the same direction as the direction of the motion of the wave. Such a wave is called longitudinal wave. Longitudinal wave. Sound wave is also example of a longitudinal wave, right? Because in sound wave, the medium particles oscillate in the same direction as the direction of the wave. So sound wave is a longitudinal wave. Then we have skipped one page. Where's page two? Right. This is my okay. So the sound wave is a longitudinal wave. The wave produced in slinky, which we discussed, is a longitudinal wave, but the wave produced in this surface of water is a transverse wave, or wave produced in this string is a transverse wave. See, here wave is going in this direction, let it be x, but the medium particles are oscillating at right angles to the direction of propagation of wave. Now, such waves are called transverse waves. Transverse waves. So, if the wave is propagating in the same direction as the direction of motion of the particles, wave is longitudinal. If the motion of the medium particles is perpendicular to the direction of propagation of wave, wave is transverse. Electromagnetic waves are also transverse. Why so? Because the electric field variations or magnetic field variations in an electromagnetic wave are both perpendicular to the direction of propagation of wave. So it is also an transverse wave. Now, so wave can be transverse, wave can be longitudinal. Then another thing which you need to remember in this elementary clarification on waves, this is an elementary idea. We define certain parameters of the wave. For example, we talk of wavelength, we talk of time period, we talk of amplitude, we talk of frequency. How we define these things? See, let us consider this sinusoidal wave in this string, right? This wave is going this way with certain velocity. Somebody has given a jerk in this string in this direction of this sinusoidal wave propagates, you can see distance between the 2 points in the wave having same phase. For example, this point, let me name it point P, let me name it point Q. This distance is called wavelength. This wavelength is represented by letter lambda. So this is wavelength. Now what's time period? See, when wave propagates through the medium, what happens? The medium particles oscillate. They oscillate, for example, from this mean position to this extreme position, then come back to the mean, then the particle goes to second extreme, then comes back. Now, at any point in the medium, when one full wavelength passes through the point, then it will execute, let me this some point R, it executes one complete cycle of motion. Now, the time required for any medium particle to complete one cycle of motion as wave propagates through the medium is the time period of the wave. Now, what is amplitude of the wave? Amplitude of the wave is the maximum displacement which the wave can produce in the medium particle. This distance is the amplitude of the wave, right? The maximum displacement produced by this wave in the string particle from the mean position. Now, the frequency is simply the cycles per second. We know a wave completes one cycle in one time period. So, the frequency nu is 1 over t. Number of cycles produced by the wave in unit time. That is the frequency of the wave. Now, frequency is inversely proportional to wavelength. You know, larger wavelength means smaller frequency, and smaller frequency means larger wavelength. You must be aware of this thing also, that when we talk of these parameters, wavelength, time period, amplitude, frequency, they can be in some other, you can define these quantities in terms of other physical quantities depending on the wave. For example, here the maximum displacement is amplitude, but in case of electromagnetic wave, the maximum value of the electric field will become the amplitude, right? Because the changing quantity in electromagnetic wave is electric field in the medium or space where the wave is propagating, or the magnetic field. So their amplitude is electric field or magnetic field. Similarly, when we express sound wave in terms of pressure, the maximum change in pressure is the pressure amplitude. The maximum displacement is displacement amplitude if you express it in terms of the displacement wave, right? Similarly, we sometimes classify waves on the basis of the number of dimensions in which the energy is being propagated. We can have a one dimensional wave, we can have a two-dimensional wave, two-dimensional wave, we can have a three-dimensional wave. If the energy is being propagated along a straight line in one dimension, wave is one dimensional. For example, the wave produced in this Salinki, which we just discussed, when we move it this way, wave will go along a straight line. This is a one dimensional wave. The wave produced in the surface of the water is a two dimensional wave. If there is some speaker or there is some point source of sound or some bulb, some light source, the wave produced by sun, for example, is a three-dimensional wave because the energy is being propagated in all directions. So we can have one-dimensional wave, we can have two-dimensional wave, we can have three-dimensional wave, right? So I stop here, but before stopping, let me summarize the this little introductory class or lecture pertaining to a wave. We said wave is a disturbance. Now, this disturbance can occur in some physical quantity. If in case of water wave, the disturbance is going in the displacement of the medium particles. In case of sound wave, there is displacement in the medium particles. In case of electromagnetic wave, the disturbance is in the electric or magnetic field, right? So in general, we all kinds of these disturbances we call waves. Now the wave can be mechanical or electromagnetic wave. Mechanical waves require material medium to move from one point to another point. Electromagnetic waves do not require medium to move from one point to another point, right? Sound wave is a mechanical wave, wave produced in the surface of water, wave produced in the string or string key, sound wave, all these waves are mechanical waves. Light and other electromagnetic waves, they don't require medium, they are EM waves. And then we said wave can be transverse, wave can be longitudinal. The wave in which the direction of propagation of wave is at right angles to the direction of the motion of particles. It is not necessarily it is direction of motion of particles. It can be the direction in which the parameter in the wave is changing. For example, electric field or magnetic field in case of electromagnetic wave is changing at right angles to the direction of propagation of wave. So such waves are transverse waves. We can have a longitudinal wave. Sound wave is a longitudinal wave because there the direction of propagation of wave and the direction of the medium particles is same. So they are longitudinal waves. Then we define these certain parameters, wavelength, time period, amplitude, and frequency. Then I told you wave can be one dimensional, two dimensional, or three dimensional, depending on the number of dimensions in which the energy is being propagated by the wave. I stop here. Don't forget to like, share, and subscribe my channel. Thank you. God bless you. Assalamu alaikum.